So with proofs, basically what you're looking for is you're going to have your statements and your reasons, and you put them in a nice 2-column chart like that. You always start with your given information. Whatever they give you in the problem, that goes at the top. And the reason for these is just given. Then you're going to add some other information, and it depends on the proof, honestly. For the most part, you're going to be dealing with congruent angles and sides. And you can find these from the diagram possibly based on the way it's drawn, like vertical angles you can see from the diagram, for example. You can determine it from the given info. So if like the given info says that something bisects a segment, then you would have 2 congruent segments here. And these things are all in the end goal of leading to the conclusion, or what you're trying to prove in the end. And your conclusion is down here. It says, and the question says prove blank, that's your final statement. That's your last statement right there. Okay, so in this diagram, we have triangle ABC, and we have a line down the middle, AD, and we're trying to prove that triangle ACD is congruent to triangle ABD. So first off, we're just given, and I didn't have room to put it up here, so I just put it over here. We're given that AD is the perpendicular bisector of BC. So let's just work through that real quick. If it's perpendicular, what that tells us is that that makes a right angle right there. And since it's a bisector, it splits BC in half into 2 congruent segments right there, BD and CD. So let's fill in the reasons for this. So this one says angle ADC, right here, is congruent to angle ADB. So for that, what you want to do is, we know that it's perpendicular from the given information, and all 90-degree angles are congruent, so we can write something like this. You could say, since AD is perpendicular to BC, angle ADC and angle ADB are right angles, because that's what the definition of perpendicular is, and all right angles are congruent, which means, of course, that these 2 angles are congruent. All right, and then for the next part here, it says that BD is congruent to CD. So right here, BD and CD. And we know that from the given statement already, that AD is the bisector of BC. Specifically, we can just write here that AD bisects BC. It splits BC in half, and that's where we get the 2 congruent segments from. And then finally, the last thing we're going to look at here is, it says AD is congruent to AD, and the way you usually mark this is with an X if a line segment is congruent to itself. And the reason here, since it's congruent to itself, is just the reflexive property. And then finally, what we need to do now is we need to look at, why is triangle ACD congruent to triangle ABD? And if you look at that, we have side, angle, side, and side, angle, side. So that's our reason.